Hello and welcome back again. My name is Jesse, and in today's wonderful tutorial, learn about sets in Julia. So what is a set? So a set is a collection of elements, and then there are two things that makes set totally different from any form of collection such as an array or a dictionary. Is that sets usually don't have duplicated elements, and then the order of elements in set are not usually important. And let's see what I mean by that. So how do we create a set in Julia? So to create a set in Julia, just go with this function set, and then this is supposed to be capital S, right? So with this, that you can be able to create a set in Julia. Now let's see an example. So I have a value of a, right? So a is going to be these values. I have some values like 2, 3, 2, 4, 3, then let's say 6, and then 8, right? So I have these values there, and then notice that this is having 7 elements. Now if I construct a set from this particular stuff, right, it's going to be set capital X, then a, we're going to see some totally different stuff. Now here was 7 elements. And the order was important, right? 2, 3, 4, just as I supplied. The elements are 7. But here, because it's now a set, sets are the collections of elements in set are not duplicated, right? So we said here is now 5 instead of being 7. The reason is that it has removed every duplicate. So 2, there were 3 2's, and then so it removed all of them from it, producing this particular value. So 4, 2, 3, 8, and 6. And you see that the order is not important as it was. It changed the order. So that is the difference between a set and then an array or any form of collection. So that is one thing about set. Now let's see an example of how some of the things can do with set, right? So I'm going to create a simple prime numbers. So it's going to be prime numbers, and then we have one for odd numbers, and then you have another one for even numbers, right? So these are the things that to be created. So now let's see how to a simple example of prime numbers. So let's call it as prime underscore num, right? So that we don't spend a lot of time. Then I'm going to create a simple collection of prime numbers from 2 to 19, right? Between 20. So this is going to be our prime number. And then let's create a simple odd number list. So this, to create a simple odd number, let's call it something simple. So odd number, right? Then we're going to give it as this. So let's use something simple to create odd numbers to collect. Then let's bring this one up. 1 is 2, because odd numbers must always 1, right? So 1, then 2, then to 20, right? So I'm creating odd numbers from 1 to 20. It has given us a very nice collection of 1, 3, 5 up to 19. Perfect. So let's create another one for the even numbers. So even num, and then it's going to be collect from 1 by even numbers starts from 2, right? 1 is not a part of even number. Then 20. Perfect. So we have 2 different sets. So this is 2 different lists. Now we want to create a set from all of them. So to create a simple set from this, I just go straight away with this set, right? And then you supply the value that you want. So if I go set prime number, right? So now this is going to be a set, right? It's a set of its own. So now it's a set. Perfect. So that's how to create a simple set from that. Okay, so these are the elements that we have. Now let me put these things here so that it becomes easy. Automatically a set straight away. So I have set, then end. Perfect. Right? So if I go straight away, now all of them are sets already. Right? I've created sets from each and every one of them. They're very nice format. Okay, perfect. Now let's see some other stuff you can also create. Work to no need of this. Now let's see how to work or manipulate this particular 3 set that we have. So the first thing you can do is that you can check for the union of it. So if I go with union of prime, union of, let's say, odd numbers and even numbers. So this is going to give us a union of odd numbers and even numbers. So it's going to give us from 1 to 20, right? So the order is not important. So that is how to do union. There's also another thing you can also do called the union bank, right? So with the union bank, anytime you see a bank in front of any function or behind any function in Julia, it is a mutating function. That means that it changes the argument itself, right? So now the elements apply. So now let's see an example. So we have this a here, right? We have a here, then we want to unite the a with the this. So if I go with a, then supply it with, let's say, a number like even number. Right now, see what it's going to see what it's going to do. Now this is not 11 elements. So and then you realize that now this is 11 elements. It's going to overwrite a with these things. Yeah, it's going to unite them together, but it's going to overwrite a. So that is the difference between this one and this one. So now if I go back to the A here and I check it, now it's no more going to be 7 elements, it's going to be 11 elements, right? Which is totally different from this one that is having. So that is the difference between this one and then this one, right? Perfect. So this union is going to just unite them and give you your result, but this union is a mutative function that's going to overwrite A with everything here. It is going to unite them together, but it's going to overwrite A, so that when you go back to check for A has been overwritten with the values that are united together. Now let's see another thing we can also do. We can also check for intersect. So intersect of odd numbers and then even numbers, there's not going to be any intersect because by default it can't happen. It can't happen. So it's going to return false for us, right? It's going to be 0. So because there's no intersection between odd numbers and even numbers. So in case I want to do another intersection between prime numbers and even numbers, I can also do that one. It's going to be this. Then let's go with this. And this is odd numbers, and let's go with prime, right? I check with this. Now we are going to get some intersections somewhere. Perfect. So we have 7 intersections. So that is the main difference, right? So intersection is trying to find what is here and what is here together, as in normal mathematics. Okay, perfect. So that is intersection. There's also intersect bank. So intersect bank, right? So with the intersect bank, it's a mutative function. So if I go with the A, then I supply the value of, let's say we used even numbers. Now here I say that this is mostly even and odd numbers. So if I go with even number, right, and I overwrite it, it's going to intersect it and then overwrite it for us. Perfect. So that's having 18, 20 and all these values there. So if I check for this particular stuff A again, it's going to give us total different set. Here was 11, right, and now it is 10. Perfect. So that is the difference between the intersect bank and then the intersect. Okay, now let's see some other stuff you can also do. You can also do set def. So set def is going to find the difference between one and the other. So let's go with odd, num, and then even. So it's going to give us the difference, right? So it's going to check what is here, what is in odd numbers that is not in even numbers. It's checking based on what you supply. So it's going to only produce what is here, is comparing it against this. So if I change, it's going to give us a totally different value. Okay, that is a basic difference. That is a main idea between set difference. Now let's check some other stuff. So you can also do subset. So I'm going to check whether prime numbers, right? Prime numbers, are they a subset of even number of odd numbers? Now let's see what I mean. So if I go with this particular stuff, I check it, it's going to tell us whether it's true or false, right? It's false. So that is one of the stuff we can do with this. You can do it subset. Now the other stuff you can also do using Julius latest. For example, this same thing that we have here, you can also do something like this. Go with backslash, right? Then you apply with subset, right? Something like this. So we can actually do something subset equal to here, then it's going to work. So this can also do something like this. Then it's apply the value of, let's say, odd number and then even. So you can also do something like this with this, and it's also going to work perfectly, just like that. So that is one nice thing about Julia. Like you're not even defining it, you're just using the mathematical notation for it, and it's going to work for us. So that is some of the stuff you can also do with set in Julia. So there are many other things you can also do, but these are some of the basic ones. So thank you for watching. If you have any question or contribution, you can just put inside the comment section so that everybody can benefit. And please check the links below for some cool and interesting stuff. Thank you and stay blessed.